page 2 in your homework packet. I just real quick. We're gonna still have special rights. It'll be part of your next test. That's why we're gonna still review them. We're gonna start reviewing them using more problem solving. I want to see if, just start off, we can do the first. I know that I numbered wrong. This will be in class. The packet covers daily work and homework. So there's some worksheets in there that says in class assignment. That means we're gonna do it in class. We will check it in class. I just want us to make sure we still understand our special rights, especially when they're adjacent. So I don't care. Y'all determine. Y'all did a good job on the test this class because y'all always ask why on some stuff. That don't, like, not adding stuff. Like, you have to go based on what's given. You can't assume it's a special right unless you see the 45 or you see the 30. You know, I had some other students say, oh, I'm going to do the special rights because it looks like a special right. No, you had to have proof. And so there was times when you should have just been doing the Pythagorean theorem and not telling me because it looked like the legs were congruent. You cannot do that. So where do you want to start on this problem? Which one? The short leg? Oh, sorry. All right, so that means we're going to start with the 30, 60, 90, this triangle. That's the short leg. So the 6. So if I know that x is 12, it's double the short leg, the hypotenuse. And then k would be what? Yeah, 6 square root of 3. Then from there, I could go into my m is 6 because now with the right isosceles, the legs are the same. And then y is 6 root 2. Okay? So you're still going to have to do that on your next test. Number 2, again, equilateral triangle. I just want to make sure we understand when you draw it, labeling the parts correctly. All right, it says PM is the altitude of the equilateral triangle PKO. So, but where is the P, the K, and the O going to go? Yeah, P at the top. Since it's PM is the altitude, we got to go straight down. So it has P. Yeah, but you just got to make sure that the altitude goes from P to the opposite side. And it's perpendicular, yeah. So now, because it's equilateral, all the angles are going to be equal, and the altitude bisects the angle to 30. So if I know that PK is 4, using the 30, 60, 90 triangle, we should be able to find the altitude. What would the altitude be? Short leg is 2. Multiplied by radical 3, so PM, 2 square root of 3. I'm not done grading them. Okay. I haven't even. I did like one set of a class. Okay. Here we go. Now, so we're gonna hit some of these every day as warm-ups, in addition to your homework and your packet. So make sure you have your packet with you every day. I want us to go into the reason why I have my hat on, which is trig. Okay, we're getting into trig, so get out the second packet that you should have picked up. I gave you your Cornell notes. They already have the main idea and questions in the margin, so you should have picked this worksheet up when you walked in. Get out a highlighter if you have one. See notes. Okay. Trig, you gotta understand, it's a study of relationship between the sides and the angles in the triangle. So when we label our parts now, and please pay attention because this is probably the first thing you have to make sure you do right. You will label everything in relationship to an angle. So in this first example that I have here, we're going to label everything in relationship to angle A. So circle that angle, and then the hypotenuse is always the hypotenuse. It's always the same spot, and it means it is the side. It's your side opposite the right angle. That's always, that will never change. What could change is your opposite side and your adjacent sides because it's in relationship to an angle. All right, so we want the opposite side to angle A. Which side is opposite angle A? Yeah, so I'm going to go ahead and label it opposite on the triangle. And basically we have to look across, right, to find that side. So I know most students understand what opposite means, but opposite side is that side, you could say it's across from that angle A or opposite the angle, but everything is in relationship to the angle, okay? Now, adjacent, this is the side that some students seem to forget what it means or how to identify it. We want the side adjacent to this angle A. Well, which side could it be? Say A. Okay, I abbreviate adjacent with just ADJ. Okay, now the adjacent side always intersects with the hypotenuse. Another way of looking at it, the adjacent side is like kind of right next to the angle that we're comparing it to. Okay, so some people say it's the side next to the angle or the side that intersects with the hypotenuse. Now, in order to do trig, or in order to write our trig ratios, we have to know which side is opposite, which side is adjacent, which side is the hypotenuse. There are going to be 3 trig ratios that you're going to be responsible for knowing. Sine, okay, cosine, and tangent. Yep, that's how you spell it. S-I-N-E. Just like the abbreviation, which I'm going to show you here. S-I-N, that's the abbreviation for sine. It's not sin. Okay? It's the abbreviation. Alright, so there are 3 ratios that you're going to have to know by heart. And my little headdress here and this little acronym is to help you remember those ratios. Yeah. Okay. Okay. I am Chief Sokotoa. Sokotoa helps you see your trig ratios, set them up correctly. Okay. So, the legend goes, huh? At Party City. Okay. All right. The legend goes that many moons ago, there was a brave little Indian, young Indian. He wasn't little. He was probably like 15. Okay, and he was trying to be the youngest chief in his tribe. And so, what? He was trying to be the youngest chief in his tribe. And so, this is what he was trying to do. So, he was already kind of like the fastest rider, and he used to get all the most kills and things like that. And so, he went to the medicine woman because she was like the matriarch of wisdom. On what can I do to become chief? And she goes, although you have strengths and you have brutes and force and all this other stuff, to be a chief, you have to have wisdom. You have to show great intellect. And so, although we have kind of killed a lot of buffaloes this season, our crops are not making it. And so, I'm paraphrasing. So she was like, we need to figure out a way so we can make it through the winter. We got to create a better system to keep our crops plentiful. So she gave him a problem. She goes, if you can show that you can solve this for our land, I'm pretty sure we can grant you, your status of chief. So he goes out, tries to figure it out, and he gets frustrated because he's not figuring out what can we do differently to make the crops, I guess, and the irrigation system work a whole lot better. And in his frustration, he kind of kicked the ground, and when he did so, he stumped his toe. Yeah. And he was out of commission. He couldn't do the things that he did before. And he was really mad now because he was really mad now. And so he goes back to the medicine woman. He's like, all right, what can I do about this foot? Because I'm not the brave and the best Indian that I was before. I can't figure out the problem to help the crops. She's like, oh, go soak it in the creek. It has healing powers. So as he goes to soak his foot in the creek, he had time on his hands to figure out the problem, and he did. So because he figured out the problem, um, he got to become chief. And in his tribe, when they name you based on a significant event that happened in your life that made you make that transformation to chief. So they named him Chief Sokotoa. Get it? Okay, got it? All right, now this, let me get it. It's a legend. Look it up. Okay, now let me show you how the Sokotoa will help you set up your trig ratios. Because here's the first one. First trig ratio is sine. Now, sine is always opposite over hypotenuse, and it's also always, huh? What it stands for? It shows you how to set up the trig ratios. Yeah, so like for example, if I'm gonna do sine, S for sine, and then it's O, and then H, opposite over hypotenuse. Okay. Okay. Now it's not sin, it's sine. Now since we're doing the sine of angle 1, the sine or our opposite is always in relation to the angle. So here's angle 1. We have to look across. There's our opposite, and then our hypotenuse would be CA. Sorry. And so the ratio would just be CB over CA. And you just write that ratio for that trig function. Sine is opposite over hypotenuse. Now, cosine, okay. Yeah, you can change the letters around. It's still the same. It's still the same side. All right, cosine is adjacent over hypotenuse. Now, C for cosine, that's the k, so katoa, so that's A over H. Okay? So, I'm always doing it in relationship to the angle. So, adjacent to angle 1 would be here, the segment or the side BA. So, I would write the ratio BA over CA. Okay? Okay, and then we have tangent. Okay, the tangent is always opposite over adjacent. So T for tangent, that's the TOA part. Okay, so tangent of angle 1 would be adjacent and opposite, or opposite and adjacent. So CB over BA. Okay, so all we're going to do is make sure that you can identify the correct trig function and write the correct ratio. Okay, and then we're going to talk about, well, the next part is going to talk about how to set up the function to solve it. Now, so ka toa. Okay, and that lets you remember what part goes where for your trig ratios. All right, now. All right, on the next page are your steps that you will need to follow. Okay, I also put the acronym up there. When you're using trig, you can use trig to find a missing side measurement or length, okay? And these are some steps, and after a while, after doing them, you're going to kind of skip some steps because you're going to start seeing patterns. But if you can kind of start memorizing these or paraphrase them and understand what you have to do for each step, it will help you get a better understanding of how to solve this. Now, for this first example, the right angle is going to be at B. The hypotenuse, we're just going to label that as Y. And BA is going to be X. Okay. Huh? All right, so to find a missing angle, or it's not a missing angle, sorry, to find a missing side, everything that we do with trig is in relationship to the angle. So on this first example, again, we're doing the sine of A. Well, the sine of A is that 41 degrees, okay? And so sine, again, is the opposite over hypotenuse. So I'm just going to write the ratio that represents opposite over hypotenuse. Well, opposite, that part is the 6.1, and the hypotenuse would be y. So it's 6.1 over y. So what you need to be comfortable with is making sure you can first label your angle, then label your parts, because if I'm doing sine, the parts would be opposite and then hypotenuse, and then determining which trig function you would have to use, and then writing that ratio correctly. So if I do cosine of angle A, cosine, see, that's the ka, so katoa. What would be the ratio for cosine of angle A? X over hypotenuse, so that'd just be x over y, right? Okay, so x is the adjacent side. And then tangent, that's the TOA, 6.1, I heard it, over x, okay? So just get in the habit of making sure you set up your ratio correctly. Now, if I need to find a missing side, so this is example 2 for me. First thing is to circle the angle. Oh, and I forgot to tell you something. When we talk about the angle, mark an angle you're looking at, you're never going to use the right angle. Okay? We'll never use the right angle. Ever. Okay? Our angles, we will use our acute angles. Okay? They'll be, if I need to find its, and you'll use its complement behind its missing angle. So, example 2. Who is the angle? Alright, start there. You circle that angle. Kosi, you need to do this with me. And then you label everything in relationship to that angle. Okay? So, what is the x in relationship to 67? It's adjacent. It's the adjacent side. Alright, what's the 18? That is hypotenuse. Hypotenuse is always the hypotenuse. It's always opposite the right angle. So that's after I circle the angle and then label the parts in relationship to the angle. Now my third step is to determine what trig function is associated with those parts, adjacent and hypotenuse. What trig function? Cosine. Okay. Cosine is adjacent over hypotenuse. So now I'm going to write the trig function using my angle, okay? So I would write the cosine of the 67 degrees is equal to the adjacent over hypotenuse. So that would be x over 18. Now, because I have a ratio here on the right side, it will be easy to solve this by creating a proportion. So I'm just going to put the trig function over 1 so I can cross multiply and solve it. Now, if you don't have one, get a calculator, because I need to show you on the calculator how to get to your trig functions and how to type it in to solve it. Okay, on your calculator, just so you know, and I'm hoping mine, let me see if I can reset it. Let me do it. Nope. Let me do some. Okay, if you, right underneath the control, there's a button that says trig. Okay, I know mine's going to go crazy right now. But there's all your trig functions that you're going to use. We're going to only focus on sine, cosine, tangent, and then the inverse, which is underneath it. Okay? Let me just stop this real quick. It's been doing this for some reason. It's probably your keypad's not pushed all the way in. Yeah, only using the first 3. Okay, so underneath control, there's a button that says trig. You hit that. Okay. Now let's just say, right now, let's do the sine of 45. Okay, and then so you put sine, then in parentheses 45, and you hit enter, and you should get an answer. Okay. Anyone get a different answer than me? Okay, it's possible. I wanted to see that. All right. What'd you get, Hayden? You got 7.7. Anyone get a different answer? Okay. I'm gonna show y'all. Let's do tangent. I'm gonna show you real quick. Do trigger, do tangent of 45. Entire. Anyone get a different answer than me? Oh, we got one. One. Okay, that's good. That's what I was hoping. Now, let me tell you why you have different answers, and I'm gonna show you on different calculators. When you measure trig function, this measurement here should be a measurement of an angle in the triangle, right? Okay. Now, when we do trig, and I'll show you how we use it with the Cartesian plane. Just do this, because if you get crazy answers, and I want to show you what a crazy answer looks like. Real quick, I'm going to show you my my menu, my document setting. So if I go to 5 to settings, and then I go to my document settings, let me hit that. See how it says angle right here? My angle is being measured in radians. Okay? That's different than what your angle is being measured in. Okay? Exactly. We are using degrees. Okay? I will show you radians because that's looking at it on the Cartesian plan. We're looking at the R and the Y. That's different. We are using degrees. All our measurements inside our triangle will be degrees. Yeah. Okay. Mine is wrong. I gotta fix it. Mine is wrong. I gotta change mine to degrees. Yeah. And so I'm gonna make that my default. So that when I go back to my document, I don't want to save that. And I do my, oh yeah, it's gonna do that again. The tangent of 45, I should get the same answer as you now. Go to settings, go to document settings, and it should say degrees where it says angle. It's just, yeah, you should have got one. I had different because mine was radians. You're right. All right, so I have the same answer as yours now. Okay, everything has to be in degrees. All right, so back to our notes real quick. Look at your note sheet. We are now going to cross multiply, and we're going to end up having to use our trig functions on our calculator to get our answer for our side length for this x. When I cross multiply, well, 1 times x, you already know, that's x, right? But now I'm going to cross multiply right here. That's going to be 18 times the cosine of 67, okay? So that is what we're going to type into the calculator. We are going to do 18 times the cosine of 67 degrees. The cosine is 67? Yeah, 18 times trig cosine 67 degrees. Okay. All right, now, when we find missing side lengths, they will indicate what you're going to round your answer to. Like, for example, I can say round to the nearest hundredths, okay? Okay, I'll go back. If I round to the nearest hundredths, that would be this 3, and then I would look to the right of that, okay? So would this be rounded up or stay the same? It stays the same. So I'm going to come check your answer real quick. So x would equal, the side would be 7.03, okay? That would be the measure of that side length. I'm going to come. Now, circle the angle, label the parts. For example 3, see if you can come up with the trig ratio or the trig function that you would use to solve this one. I'm going to pause this for a bit. All right, if I circle my angle first, then label the parts in relation to the angle, I have opposite and adjacent. That would be tangent, okay? That's TOA, opposite of adjacent. So there will be tangent of 43 equals x over 9, okay? Now, put it over 1. We're going to cross multiply. So basically, x is going to equal to 9 times the tangent of 43. So that's what we have to type into the calculator. 8.39. Okay, so 8.39264. All right. Again, we're going to round to the nearest hundredths. So if I round that to the nearest hundred, what would that end up being? approximately 8.4, right? Okay, now, here's what you need to know when using trig functions. Do you notice where the x was in our proportion each time? Okay, and then what did you have to do to solve for the value each time? Multiply, yeah. Whenever the x is on top, okay, that's what I'm trying to get you to understand. When x is on top of the proportion, you multiply. You multiply the number times the trig function. Okay? You're just going to multiply when x is on top. So that's like a little shortcut that you could use to help you. So, with that being said, go to the next page with me. Okay? We're going to continue. Do you need that? Function, yeah, whatever the trig function is. Okay? Alright, so look at the next example. We're going to go through the same steps. Circle the angle. Circle the angle, label the parts. So, we circle who? 52, right? And then we label the parts in relationship to that angle. We got opposite at the 20. X is the hypotenuse. All right, so what trig function? That's the next step. Sine. All right, so we're going to write sine of 52 equals opposite, which is 20, over the hypotenuse, which is x. We're still going to put it over 1. Now, notice where x is now. At the bottom, okay? Are we going to multiply here? Okay, yeah, guess what's going to happen? We're going to divide. I'm going to show you the cross product. If you cross multiply here, 1 times 20 is 20. And then the sine of 52 times x would be x times the sine of 52, right? Now, oops, I put 4. What would you have to do to get this x by itself? You divide. So we would have to divide it by the sine of 52 on both sides. That would cancel out, okay? And so basically x is, and I'm just going to write it, now 20 divided by the sine of 52. So now we're dividing to get x. Okay. That's right. 0.38, right? Yeah. So you got 25.38. What was the next one? 0.4? All right. So if I round to the nearest tenths, because that's another thing I would ask you to do. Okay. If I round to the nearest tenths, this would be x was approximately 25.4. Okay. Now, so if you notice something, let's look at the next one real quick. I'm going to show you a little shortcut that happens, basically, because we're doing division when we cross multiply, when the x is on the bottom. 24 is our angle. 24 here for BC is our opposite. X is our adjacent. Sorry. Then I determine what trig function that would be. That's tangent. Okay, I'm going to write tangent of 24 equals 24 divided by x over x. Okay. Now, if like I said, x is now on the bottom. So what operation are we going to do when x is on the bottom? Divide. So a shortcut, whenever you see x is on the bottom, you need to just switch these two. I'm just going to switch them. Okay? So if I switch them, x is going to equal to 24 and then tangent, divide by tangent of 24. Okay? So y'all see that? You just switch them. Yes, you just switch it. So we have to go in our calculator and we have to say 24 divided by the tangent of 24. Yep. Okay. 53.9. Are we good on that? Okay, so another way to think about it is that what to do every time x is not on the top? I fixed that. It's a typo. When x is on the bottom, one way to look at it is switch the x, okay, and the trig function. Oops, trig, not big. Okay, switch them, and then divide. Okay, switch the two, and then just divide when x is on the bottom. Are we good on that? All right. Now, I need you to go to your homework packet because I want to show you what your first homework check is and what it's going to entail. And it's going to be over these notes. Okay. So, in your homework packet, the first one we're going to do is, this is in class when we come back. Go to page 5. Yeah, trig ratios. Okay. Now, they've given you examples just in this box. What they want you to do, you can use the straight edge or just kind of guesstimate. You're going to match the trig ratio and its value. Okay? And the uncrossed word is the word that you're going to use to reveal the message. So, for example, sine of B, that means we're using angle B in relationship to label the parts. So, if I'm talking about sine is opposite over hypotenuse, right? So, which number or which part is opposite over hypotenuse? Opposite of B. Yeah. Yeah, so that would be 4 over 5. So I look over here. Here it is. Opposite over hypotenuse 4 over 5. I'm going to connect this dot with that dot for B, sine of B. Yeah, because it said sine B. Yeah, so we're not going to use get because it went through that. All right, now we're going to do cosine of B. What's cosine? Yeah, adjacent. Who's adjacent to angle B? The 3. So we're going to do 3 over 5. So that would be here as such. What letters? I'm not. Yeah, it gives you. You're just connecting the two though. You got to connect the right one. Yeah, down here we have to. Yeah. All right, opposite of adjacent. Yeah, but you have to pick. Like here, I don't have it listed anymore. You have to pick the right ratio. So this yours is the first one. Yeah, whichever one doesn't get crossed out is the one that's revealing the message. So here we're doing sine of 30. Opposite over hypotenuse. So that would have to be, oops. That would be 1/2, right? Does that make sense? Sine of 60 would be the square root of 3 over 2. Okay. Yeah, I mean, you still have to match them up. Just make sure they're matched right. Page 5, all of it. The next puzzle is on page 6. Okay. Homework. Okay. And then page 7. Yeah. Yeah. Hold up. 5, 6, and 7. 7 is just the evens. Yeah, I'm gonna put it on Moto. Yes, it's due on Tuesday when we come back. Oh no, 7 and 8. Yeah, the front and back. Okay, 7 and 8. All right, I need you to put up the calculators, and we need to go ahead and